out there, but there is a few of you in here that think at a different level, okay? And you like to see another way to do things, and you're not all like, oh man, another thing to know, that sucks, right? But you're actually kind of looking for, okay, that's cool, I can use that too, and back it up. Now I'm going to skip this chart because it'll make things more confusing than better. Now, here's what, there's a bunch of stuff here, and we want to always simplify it, right? Anyone can make math complicated. Yes, I am, thank you. I mean, to make math complicated is super, super easy. To make it super, super simple is always the challenge, right? To translate, to figure out what's going on. Now, let's just do this question right here, but I want to do this. Look right here. 10 squared. What does 10 squared equal? 100. 10 times 10 is 100. Okay? Now, log 10 of 100 equals 2. It is interesting because we can take something from this. So I want to just look at this. What if I said, let's call the 10 the base. Let's call it, say, b to the x equals a. Now this is where we really gotta figure things out. So this is b, that's x, and that's a. How would it look if I changed to log form? It would be log. What is, in our example, what's b? 10. So in our new one, that would go there, correct? What would go here? Look, b to the x equals a. So a would go here, correct? You see? I know this is weird at first, but it's only complicated for like 3 weeks, and then it gets easy. So, I'm joking, hopefully. But if b to the x equals a, this is b, that's x, that's a, correct? In our formula. So, over here, a stands for 100. So, a is going to stay 100. b is 10. b is going to stay there. And x was 2, right? So this is huge, okay? That is what you need to know. Now, what did not move? The base. Base stayed there. I put a log in front and switched the other two. Okay? So to go from here to here, let's put it in layman's terms. Let's bring it down as much as part, okay? B stays. So I'm going to, my arrow from here to here. What happened? B stays. Put a log in front of B. And 3, switch A and X. Okay, that's what's going on. So if I could do maybe a nicer question, let's do 3 squared equals 9. Can you put that in log form for me, please? 3 squared equals 9. Can you put that in log form so it is true? And then I want somebody to give me what they wrote down. Yes?
Log 3 to the 9 equals 2.
Okay. Well, maybe you're right. I don't know for sure. So I'm going to use my little thing with keys all over it, and I'm going to check it out. How did I put this in my calculator? Do you remember? Log 9 divided by log 3. Okay. So, to know how to do this is crucial. To not know how to do it, it'd be like, you guys, let's write essays today. And you're like, yeah, but I really suck with that alphabet thing, but I'll be okay. No, it might be hard. Like, how many parts of the alphabet you missing? Oh, just like 6 or 7. No big deal. Let's go. Right? It might be hard. Like, is A one of them? Yeah, kind of not good with A. So if we could stay away from A, that would be awesome. Okay? You're already limited, right, to what everybody else. So this rule is huge. There's so many rules. It's kind of like if you're playing a game and you don't know the rules, you'll be so frustrated. You'll be like, why did I get whistle again? What is going on? You're offside. What's offside? You better figure that out, right? Yes? Log 3. I'm going to get rid of this one. Log 3 divided by log 9. So you put log 9 divided by log 3. So how I put this in was log 9 divided by log 3. If you learn every single thing, every trick that I tell you, you will get 100% on this test. You just will. Because you'll do it 3 times. I got the same answer. I know what's right. And it's not like one way takes any longer. Okay? There's, well, let's go to the next page. It's hard for me not to get ahead of myself and get excited. I love this log stuff. Okay, so we got log 10 of 500 equals 2.698. Can you write that in exponential form, please? See, this is what's called log form. You know why it's called log form? It has a log in it. Okay, exponential form. We did a whole unit on exponents. Let's not forget what we know. So write that in exponential form. And I guarantee if you do it right, it works out in your calculator. Okay, so how would this be in exponential form? Who wants to take a stab at it? I know it's scary stuff, but what would it be in exponential? Yeah? Okay, did you try it? Put it in your calculator, see if it works. 10 to the exponent 2.698. Does it work?
498.8.
Yeah, it's good enough. Eh? Okay, you can obviously tell they rounded, because what's log 500 divided by log 10? I bet you that thing goes on for a couple hundred decimal places. Okay, and that's what we got to get to. See, 2.698, that's rounded. Exact answer is log 500 divided by log 10. Okay, that's what it equals. Okay, so let's just skip this little box, and we're gonna. This is the money right here. Log b to the n equals x, and b to the x equals n. So do you see how to go from here to here? Get rid of the log. Base stays the same, and these two interchange. Does that make sense? Get rid of the log, keep the base where it is, and these two interchanged. So let's do these really quick. Let's get all these, because they're all in log form. You know why I know they're in log form? They have the word log in it. Okay? I don't want to make this magic, right? It's got log in it. These are log. We want to go to exponential. What would the first one be? Now, what's not moving? 7. The other two interchange. 7 to the 4 equals x. Do you see how these two interchanged and I got rid of the log? Why? Because I'm in exponential form. You guys would have thought that was weird if I was putting the word log in front of all of our exponential equations before, right? Where are you getting this log from, right? I thought this was exponential. So it should be weird now even. Okay, next one would be what? 10 to the 3 equals 1,000. And that's true, isn't it? Now this one's tricky. Not too tricky for you guys, but it's tricky. Okay? Do you see? We do not want to change the rules. Now do you see how this entire thing moved over here? This entire thing is going to move over here. Don't get freaked out that there is an exponent, that there's an exponent over there. But let's do the same rules. What's my base? X, b to the d equals a. Now they want to see if you'll freak out, right? Will you go off the rules you know? Just because I put an exponent up there. Okay? Now, let's go to log form. Why do you know they're an exponential? Because they're an exponential, right? So, if you're going to go to log form, you must write out the word log. What's not moving? 4. The other two? 64. Now I'm not good at this, right? My 64 should be in the same level as the word log. I'm always writing it too high, so I'll keep. And that equals what? 3. Okay, b. No, log 2 1/8 equals -3. Okay, this one looks scary. Okay, what's the base? No, it's not.
Everything in the bracket.
Everything in the brackets. So they put it on the other side, and we're like freaking out all of a sudden, right?
I got it.
Okay, well tell me what you got then.
I got log bracket 2x plus 4 to the exponent a.
Not to the exponent a, that's to the a,
Yeah, to the a equals
-1. Okay, do you see how these two traded? I kept the base the same and put log. So that's supposed to say 2x plus 4. I don't know if it's... So let's do one more, because I don't want people freaking out. What if I did 32 equals 2 to the 5? Now that's a true statement. But how would I write that in log form? Which side is the log going on here? On the right side, isn't it? That's where my exponent is. Don't move the base. The book will move the base on you sometimes. They'll do it on the other side. I never teach that. It's a bad habit. Keep the base where it is. We've always said leave it with. So I'm going to go log 2. Why? Base stays the same. What am I writing by the 2? 32, and this is going to be 5. Sort of making sense? We'll do the same thing every time. Okay, and that's why you want to practice these in the homework. Check them out. Make sure you're doing okay. Okay? Now, 32 equals 10 to the y. The only way you've been able to do this before is y1, y2 to find that exponent. Let's change it to log form. What side is my base on? Right. So this is going to go log 10, correct? What's going beside it? 32 equals y. Now, how do we put that in our calculator? Log 32 divided by log 10, right? Since 32 is the higher one, do it first. That makes sense, right? Okay, that's how we're always going to remember it. What do you get? Equals 1.505. So you get that. You're like, I hope it's right. Can you check it? Go back and put 10 to the 1.505. See what you get. Because that's your y now, right? This equals y. Shove it in here. See if you got it. 10 to the 0.1505. What do you got? Now we rounded a bit, so it's going to be a little bit off. But you're going to be pretty darn close. What do you get? How much? 32.198? Was it that far off? Okay, so it is 32. Okay, now let's not do anything different with this next one. How would we write this? First of all, where's the log going? Right. What's not moving? E to the 25 equals y. Now, what is log E? Ln. Remember I told you yesterday? Log E equals ln. Right? That's that other button in your calculator. So, go ln 25. So y equals 3.219, isn't it? 219. Now, what if you didn't even see that? You're like, I wouldn't have saw that. I wouldn't have thought ln. Could you still have done this in your calculator? Let's do it. How would you put this in your calculator? Log, there's no 10. Come on. Log, top number, over, log, bottom number. Should get the same answer, right? Sorry? E is E. E is this button right here above the division sign. So you would put, okay, just because I'm here anyway, I'm going to do it. Second, E to the exponent 3.219. I hope I get 25. Close enough. Now, ln 25 is the exact answer. Okay? The approximation is 3.219. Okay? No, they might just want this. That's it. But I could still check it, because I would get the decimal, I would shove it in. But even better, what does y equal? Ln 25. So what if I went e to the exponent ln 25? Okay? Now you'll see how perfect it is. So if I go e to the exponent, always put that in brackets, ln 25. Okay, it shows you how it does give you the perfect answer. So this is what we would call exact. And this is always called the approximate. Yep.
If you were to put an approximate answer, would you, on numerical response, would you say the plus?
I would ask in the thing exact, or I would say approximate to the nearest hundredth, right? Because I'm always thinking I got to get you ready for that diploma. They're always going to be, and you know what? This could be just a numerical response. What is y to the nearest tenth? That's simple. One, you put in 3.2, move on to the next question. Can you check it? Absolutely. Okay. In this log unit, that's maybe why I like it. If you know your rules, you will have 3, 4, sometimes 5, I'm not even kidding you, 5 ways to do the same question. And you just, like after 3 times, you're like, I'm pretty sure I got it, but I got another 10 minutes. I'm going to do it a couple more times, right? And then when you do that rule, you're like, yeah, use that rule over here. So I know I did that rule right. Okay, let's rewrite this one. Now, there's so many ways to do these, it's not even funny. But let's, because it's in log form, you could just even put this in your calculator, right? It says solve for the given or evaluate. Now, how could you put this one in your calculator? How would I put this in? Log square root 125 divided by log 5. So can I give you this rule right here? This is another rule. I had the one on the last page. Oops. So the rule is if you have y equals log a of b, this is the same thing as log b divided by log a in calc. Okay, so we want to have that rule on our study sheet. You do not want to forget that rule. That's pretty important. If you have log a of b, how do you put that in your calculator? Log b divided by log a. So you see this one's on top? Make sure this is on top. The higher one goes first. Lower one goes on the bottom. Kind of makes sense. Okay? So what is that? Okay. What are you getting? 1.204. Okay, because you should be doing you shut your bracket. If you don't shut your bracket, bad things happen. Okay, now if I get out of here, now if I go math, enter, enter, I want to see what it does. See, and in it's not good. Why are you doing that? Okay, because if we switch this, and if I put it into exponential, exponential would be square root of 125 equals 5 to the y, correct? This is the same thing as 125 to the 1/2 equals 5 to the y, right? Because exponent or square root's the same thing as a half. This is the same thing as 5 cubed to the 1/2 equals 5 to the y, right? Okay, what did you get? Yeah. So what did I do wrong? Oh, I didn't shut the second bracket? Okay. That's good, because I should be getting... Yeah, I did shut my second bracket.
You did a double bracket.
Ah, there we go. Okay, awesome. I knew... I gave this for a reason, but I forgot to actually do it correct, so that's misses the point a little bit. Okay, so this is what I did. I went log. Now, when I open the square root, see a bracket opens? And I put 125. I shut the bracket for the square root, but I need to shut the bracket for all of the top. I'm glad we had this little talk. This is important, okay? And then divided by log 5, shut the bracket. Okay, and then you go math, enter, enter. Because, I know that was the wrong answer. And I know it was the wrong answer because of, what do we do to these two? Right, that's like 3 over 1, right? So we multiply those exponents together and you will get 5 to the 3 over 2 equals 5 to the y, and then we learn to cross those out. 3 over 2 equals y. Okay? So I went to exponential to prove it. Now, when you have log 4 of 64, again, you can put that into your calculator. And what do you get? So you go log 64 and close your bracket. Divided by log 4, you should get 3. Okay. This is for the last one. So I want to show you, let's not do C right now. I want to do this question again. I'm going to show you a trick. Log 4, 64. I went too high on my 64. Now, this is the same thing as log 4 of 4 to the 3, correct? Now, I want to write this really good. So the 4 is down here. Here's the 4, and here's the 3. That's considered third level. Third level gets to come out in front. Now guess what log 4 of 4 equals? Try. What do you think log 4 divided by log 4 equals? Come on. Log 4 divided by log 4. Anything divided by itself? 1. Like, does this make sense that this equals 1? So this is 3 times 1, which equals 3. So we did it with our calculator. We did it with the trick I just showed you. We could also do this. Y equals log 4 of 64. I'm just rewriting the question. Okay, so I've done it 3 ways. Here's the third way. Let's change it to exponential. What would it be in exponential? Exponential form. 4 to the y equals 64. Can I write 64 as 4 to the something? 4 to the 3 equals 4 to the y. Those go 3 equals y. What is another way you could do it? y1, y2? So this I changed to exponential, and then I did what we did in the exponential unit. Got them to the same base, right? Went up. Now, let's just have, I know you guys are like, yeah, when I say let's have fun with these, you're like, yeah, whatever, it's math, come on. Okay, but let's do this one without our calculators. Log 2 of 16 plus log 2 of 2. Now, what does this equal? Everyone up here? It equals 1. Now, what is log? Can I write this 2 to the something? 4? Yeah, 2 to the 4th is 16. So what can this 4 do? Come to the front. So, what does this equal? 4 times 1 plus 1, which equals 5. Yep. Because if I was to put this in my calculator, I would put this like this, log 2 divided by log 2, wouldn't I? And what's anything divided by itself? Always equals 1. So you can put it in your calculator and you get like, oh crap, that equals 1. But after a while, you'll just know log a to the a equals 1. How about 5 log a to the a? 5. What about log a to the 5? 5, because that 5 can go there if you want. Now, here's what's going on, okay? You just moved to a new city, and you're like, can someone tell me a way to get to work? And a guy goes, I'm going to tell you 10 ways to get to work. And you're like, I don't want to know 10 ways. Just give me one way to get from my house to where I have to work. I want one, okay? And I get that, right? So the reality is I'm showing you a bunch of ways, but you could have just put this into your calculator right away as log 16 over log 2 plus log 2 over log 2, correct? You could have done that, and I know you can do that. But I kind of wanted to show you, well, what if you put it in your calculator wrong? Could you catch it, right? Now, so anyway, you need to have those rules written down. Log a to the a equals 1. As long as these two are the same, it equals 1. Now I want to show you another way to do these. Okay? Now, whenever you have two logs with the same base,
Excuse the interruption. Mrs. Thompson, Mrs. Leanne Thompson, please contact room 321.
whenever you have two logs of the same base and you're adding them, you can multiply this level. So if you had log 2 of 16 plus log 2 of 2, this is the same thing as log 2 of 16 times 2. Okay? So if you're adding, and they are the same base, you can multiply that level. This would be the log 2 of, what's 16 times 2? 32. This is the same thing as log 2 of 2 to the, what's 32? It's 2 to the what? It's 2 to the 5. What does this equal? 5. Okay? So if you would have done it this way, you would have got 5. If you did it this way, that I've shown you here, you get 5. And if you know this other trick, you get 5. Now I'm going to teach these tricks over and over again later. Today, can you do this? Okay? But are some of you going to go, hey, that's 1. I remember that being 1. So you're going to put it in your calculator, you're going to get 1. You're going to be, oh yeah, okay, that kind of makes sense. So it is a bit of a, like, I know it's a lot at one time, but it's good stuff. Okay, here's what you're going to get on your diploma. Something like this looks very, very ominous. The Richter scale. You guys might have heard of it. Earthquakes, right? Now, whenever you hear something, it was a Richter scale, or they had a magnitude of 9. Okay, what that means is 10 to the 9th power. Okay, that's how strong it is. So if you had a 10 to the 9 earthquake, and another country had a 10 to the 8th earthquake, country A, their magnitude was 9. Country B, their magnitude was 8. Doesn't sound that much more powerful, but it's actually 10 times more powerful, right? Because 10 to the 8 and 10 to the 9, how do you get from 10 to the 8, 10 to the 9? Multiply by 10. So they go by tens. Now, here is the formula they will give you right in your statement on your diploma. And I want you to know the difference between intensity and magnitude. Now, magnitude is always going to be your m's, okay? And this is intense. IT, okay? Now, do you have to memorize this formula? Absolutely not. Do I want you to be familiar with it? Yes. Do I want you to go, I've seen that a million times, done a lot of those? Easy. So, if you have that formula, it says how many more times intense was the 1985 earthquake, 8.1, and then the Turkey one, 6.9. Now on your diploma, they'll have 8.1 minus 6.9. They'll have that answer there. It is the wrong answer. They will have that there for you though. Okay? They have to have that for students that they're just showing up. They're like, I haven't shown up all year, but I'm going to try this diploma thing. Can't be that bad. A lot of people write it. Right? I'm going to go for it. But we're going to follow this formula. Now, I1 over I2, we do not know either intensities, equals 10 to the magnitude 1 was 8.1 minus magnitude 2 was 6.9. Now, you want to put this in brackets, and you're just going to put that into your calculator. So we're going to put 10 exponent 8.1 minus 6.9. Now, how much more intense was the first one? Or how much more intense is it? What did you get? 15.8. So therefore, it was 15.8 times more intense. Will there be people going to the diploma could not do this question? Absolutely. Okay? Know your magnitudes will always be those exponents. Okay? So when they give you the Richter, okay, this is your magnitude, right? Those will always be your exponents. And I'm going to do more of these with you. We're going to spend a whole day on one question of the diploma. Right? But that's kind of what we do every day. And maybe we're going to spend a day on something. You're not going to pick that for the diploma, but because I don't have my crystal ball with me, I don't know which ones they're going to pick. Right? So we're going to prepare for the worst and hope for the best. Right? You should ask them. Yeah, they'd be pretty forth. I know a lot of guys up there. They do not give you, right? But you do enough, and they do that same question every time. Okay, here's another one that goes by this, and that is you might have heard of this, the pH scale. Okay, pH is another logarithmic function, exponential. Now, here's kind of, they'll give you this chart. They'll tell you where the lower the number, the higher the acidity. Like 14 on the pH. pH 14 is very basic. Okay, 0, big, acidic, ouch, burns, right? And you know what? High bases burn too, right? So it's not really. And what happens if you mix a 0 with a 14? They neutralize, right? And they become a 7. And a 7 is, right, milk, or basically anything that you'd be drinking is going to be in this area. Okay? Now, again, big scary formula. Ooh, pH equals negative, oh, log. What is that thing? I don't know. Put it in your calculator. You got a log button, put it in, right? You've probably even dealt with these in chem and stuff. Okay. So the pH, so again, they will give you this on the diploma. They will give you this formula. Do not freak out. Okay? Just, so we're going to do this one. A patient gave a urine sample found to be a pH of 5.7. What was the hydrogen ion concentration? Now right away you're like, holy crap, what are you talking about? How am I supposed to know this? Well, they give you this formula. pH equals negative log H plus. Now, what do we know in this formula? pH. So I will put a 5.7 equals negative log H plus. Now, that log is on the same, or that H plus is on the same, right? So one thing that you should know, because there's nothing there, there's always a 10. If there's nothing there, it means 10. Okay, so if you have just log x, I guarantee you there's a 10 there. Always, 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 always. If it's not there, it's like 10. Means it. It's like if I do this, square root 25, you're like, is that cube root? Is that like fifth root? Like, what am I supposed to do? Right? Because there's nothing there, it always means square root. Okay? Same thing if nothing's there. So, the first thing I'm going to do is I'm going to divide the negative out. Negative 1 on both sides. I will get negative 5.7 equals log 10 to the H plus. Okay? So you're going to do that on your diploma. Now, how would I solve this? Switch it to exponential. So this would be, on the right side, what would I write? 10 to the exponent, negative 5.7. What's on the other side? H plus. And that's what they wanted. What is the hydrogen ion concentration? This is hydrogen ion concentration. Now, will I make sure you do a few hundred of these for the diploma? Yes, I will. Right? But this is key. How do you solve this? It is hard. You know the one rule, how to switch to exponential? That's easy now. That is an easy question. 10 to the exponent. So you're going to put this into your calculator, and you will get, what do you get? Okay, so if we round, it's going to be 2 times 10 to the negative 6. And that's moles per liter. Okay, do they tell us that? No, but you know that from chem, right? Yep. So 10 to the exponent. Oops, crap. And then I'm putting negative 5.7. What is second function log? Enter. See? 2 times 10 to the negative 6. Yeah, you know what? Whatever they ask you to round it to. This would be a multiple choice question for sure. Okay, so I want you to know where I got my -6 from. Now this E, that's not the same E we've been dealing with. That's a capital E. That means times 10 to the -6. That's what this means. Okay? Okay. What's up? Moles per liter is the units for. Okay, can we just summarize today? If I have log a to the b equals x, what would that be? This is called what form? Log form. If I want to change to exponential form, what would that be? A to the x equals b. Okay, that's pretty big. In fact, if you know how to do that, you probably know how to do half the unit already. Okay, the other thing that I wanted to show you is log a to the a equals 1. Okay, and to test, how would I put that in my calculator? Like, you go log a divided by log a. Now right away you should be going, hey, that should equal 1. Because I don't care what log a, if log 20 divided by log 20, it should be the same answer at the top and the bottom, so you'd equal 1. Now what would log a to the b equal? B. Okay? Also, oh, can I do this too? How would I do this? Is the same thing as b log a to the a, which equals b. Okay, how about this one? If I had log a to the b plus log a, okay, this b is supposed to be right there, to the c. Who remembers this one? Yeah? Oh, you could do it that way, but what's the rule I taught you? If you're adding and these bases are the same. So if bases are the same, this, you keep the base, and what do you put here? B times C. Now I'm going to give you one more, just because I like you. I wouldn't do this for anybody else. If I had log, now let's just, I'm not going to show you the answer, but I want you to see if you could write this as one log. Just try it. Nothing's going to happen if you get it wrong. Nothing's going to blow up. No one's going to get hurt. Hopefully no one cries. Right? I want you to try it. It was worth $1 million to you. Try it. It's not. But what if it was? What would be your answer? Okay, just try it. Write it down. Who cares? Write it in pencil, because then it will erase and we get back into life again. Just try it. Okay? Who thinks? Okay, yeah, well, which one? Good question. Okay, somebody give it to me now. What are some guesses? Let's go with guesses. Log A. That's correct. Yeah? Okay, what? What?
So with the log a divided by log a, you get 1, right?
But we don't have a. This becomes one base. The base. You only divide these two. Okay? Now, these are two rules that I'm going to, so this is the everything you need to know for this unit. Okay? This one here, Math 31, or sorry, 30-1. But I think it will help you. Okay, it will not hurt you. This, again, math 30-1. But it should make sense because this is log A divided by log A. And this third level, this is going to come in handy. Okay? And as we keep going, we are going to, like I even have, I'm going to tell you right now, I have a 30-1 question on diploma, or sorry, on your unit exam. It's a bonus, we're 2 marks. Okay? So I'm giving you a bonus on that one because it's a 30-1. You do not need to know it for 30-2, right? But what if you can get it? It's worth 2 marks, a little bit of confidence that, right? Because tons of this stuff is from 30-1, and I think if you knew a little bit more, it makes it easier. And 30-1, students really do well in this when they know all the rules. Okay? So you're going to go to the homework and you're going to think it's kind of a joke because we have gone to a much higher level today. But throw a few of those rules down you've learned and see if you can stay away from your calculator. Like this one here, log 10 of 100. Without your calculator, could you do that one? What is that? What's the answer to this? No. Okay, how about we get this? What if we got this? The answer is 2. Because we could make it look like this, could we not? By going log 10 of 10 to the 2. What is third level? Comes to the front. 2 times 1, which equals 2. So what I'm saying is, you're like, you put this in your calculator and you get 2. I want you to go, does that even make sense? Oh yeah, that makes sense. Because that's the same thing as log 10 to the 10 to the 2, and we learned that if those two are the same, third level's the answer. Yes? This way? There's 4 or 5 ways to do every question. So the way that you like, but we will learn this after, where you'll just have to be doing some of these. Right? So then you'll be using it then. And it's fun when students start to go, I wouldn't even do it that way, I would have done it this way. And I go, yeah, that is the smarter way. And sometimes when that's the day we're doing, they just want you to keep doing it that way. But some students will start going, but why didn't you just do this? Would have made half the work. Right? Then you're starting to see how other rules help you. So again, when you just move to a new city and you need to find how you're going to get to work, just one way, please, right now, until I'm good at it, right? And then and then you can teach me maybe some shortcuts, stuff like that. So you'll see if you want to just stick with your calculator today, you're going to be fine, right? But my goal is that you're all getting that bonus question on the test. Yes?